Alright, so today I'll be starting a new exercise on SDL, which is aptly named scrolling. Okay, so here we are, and up till now we've only been dealing with levels the size of the screen. With scrolling, you can navigate through levels of any size by rendering everything relative to a camera. The basic principle of scrolling is that you have a rectangle that functions as a camera. Okay. And then you only render what's in the camera, which usually involves rendering only things relative to the camera or only showing portions of the objects inside the camera. Okay. Okay, so the dimensions of the level. Okay, so I need to make these changes in the game file. Game.c. There is game.h. Here we are. I need to make action constant level width. Again, action constant level height, and I will define them. Level width equals to 1280. Okay. Then, since the level is no longer the size of the screen, we have to have a separate set of constants to define the level size. Okay, these are the separate constants, and I've spelled height. Yes, height. I hope I have spelled it right here. Alright, so we have the dot that will move around, then we have this maximum axis velocity, and render position excessive. Okay, render. Okay, shows the dot on the screen relative to a camera. Okay, this time the dot has to render relative to the camera, so its rendering function takes in a camera position. Okay, so this time we have to make changes to the render function, which the dot it will take int cam x and int cam y. Okay. Position exercise, velocity position. Yeah. Okay. Then okay, then we have to update the move function too. Okay, move to the left, the dot went to, yep. Okay, now level width. Now the only difference we have to do is to change level width. Move, this is the move function. Okay, so I have to get rid of all these. Now we will be passing the level width and the level height. Let's get rid of these and position shift collider. Okay. Okay, on the x-axis it should be uh, right. So dot position of the dot x should be greater than 0. Okay, if is less than 0, or dot position dot x plus dot width is greater than the level width, right? And a bracket again. Okay, so see, what this means is, say I have my level over here, and then I have, okay, let me draw, this is x, um, yeah. So this side y, this side x. Okay, so if the dot position which is to be measured here is goes here, right, less than 0, then obviously it is going out of the screen, which we don't want. And on this side, level width, now this whole screen from here till here will be the width, level width. So if see, since we are measuring from this point, so this point plus the width of the should be, if this point exceeds right, uh, so what we are doing is we are adding the x plus the width of the dot. So our point is shifted here, and we check if this position is, if it starts going greater than, then we will move it back, right? Okay, velocity. All right, then we'll do the same here. Hmm, I should, if it is, okay, less than 0, right? And then if dot position dot plus dot height is greater than level height, we move back, and since we are not dealing with colliders, so we won't be needing them here. We get rid of this. Okay. And then this time when moving the dot, we check if the dot moved off the level as opposed to checking if it moved off the screen. Since the screen is going to move around, it's going to move around the level. Okay. Now we provide it with the render function definition. Okay, so render texture dot position. I need to take this here, int cam x and int cam y. we are subtracting from the positions. Okay, now when we render objects to the screen, we render them relative to the camera by subtracting the camera offset. Huh. Camera offset. Let's see what it means. We have we have this. Okay, this is our whole screen, right? Nice and centered. Then let's say this is our camera. Hmm. And this is position. Okay, let's see if its position is say relative to the screen, then by 10, right? And then okay, this is 0, 0, and my camera is at right. So render this dot, we give it the coordinates of 5 by 5. But why? Hmm. Why would you do that? Okay. Okay. Now when we render objects to the screen, we render them relative to the camera by subtracting the camera offset. Okay. The camera area. Alright. I have defined center the camera with the dot. Keep the camera in. Okay, let me implement. See, we got this right. Level width, level screen. Right, then we have I have to define the camera. I think I won't be needing these. I would have to do a lot of cleaning up, but I need to define a camera, STL direct camera. Okay, get that. STL direct camera. Alright. Then we provide this camera some. Okay, so by default, the camera is as big as the screen width and the screen height. Alright, so before we go into the main loop, we declare before we go into the main loop, we declare the dot and the camera that is going to be following it. Okay, we move the dot. Where is the dot moving? I think it's in the update function. Yep. Okay, and okay, we are moving it, and I would need to provide move, right? Dot move level width and level width and level height. Okay, we are move the dot here, and then we need to center the camera over the dot. Okay, so keep the dot in the center of the camera. All right. Dot with, can I access this dot with static count? Okay, dot. Static. Okay, we'll see if it will throw an error, but for the time being, let's just roll here by 2, right? Minus screen width by 2. Okay, and then y plus by 2, and keep the camera in bounds. Okay, so if camera is less than x, camera dot x is less than 0, we bring, okay, we shift the camera here. Okay, if camera dot y is less than 0, we bring it back. If camera dot x is greater than level width minus camera dot width, level width is greater than camera dot x. Okay, first keep the camera in bounds. So if camera dot x is less than 0, we say force it to come back at its place. Same if camera dot y is less than 0, then we force it at its place back, and if camera dot x is level width minus camera dot width. Okay, and okay. Then after we move the dot, we want to change the camera position to center over it. We don't want the camera to go outside of the level, so we keep it in bounds after moving it. Okay, see, ये वाले पॉइंट्स तो क्लियर है कि अगर कैमरा की पोजीशन 0 0 वाली तो समझ में आती है कि इसको वापस 0 पे वापस 0 पे करता हूँ, ठीक है। फिर अगर कैमरा ये है विड्थ और ये है हाइट, तो camera dot x is greater than level width. ओके, तो ये लेवल की विड्थ है, मतलब कैमरा की विड्थ, लेवल विड्थ माइनस कर रहे हैं हम कैमरा की विड्थ। ओके, अगर इसकी पोजीशन लेवल विड्थ माइनस कैमरा विड्थ से कैमरा की विड्थ लेवल की विड्थ, अच्छा रुक जाओ, इसको पहले पूरा करते हैं फिर सोचता हूँ मैं जरा। क्लियर स्क्रीन, जी background texture dot render, ओके, इसमें मेरे को उसका टेक्सचर लोड करना पड़ेगा, राइट। ओके, आई थिंक ये वाला टेक्सचर इसमें होगा, so I'm gonna download it. इसको कॉपी करते हैं एंड एथर्स में ड्रॉप कर देते हैं पीजी। ओके चलो, बैकग्राउंड लोड करना है, तो game dot h game dot c texture background texture, ठीक है। तो ये हो गया चेक रेंडर, यहाँ पे मेरे को लेते हैं high question texture load from file render and fit bg.png. I hope png और टेक्सचर कर सकता है, राइट। टेक्सचर डॉट एच specified file path, ठीक है। Okay, then we will check not equals to false, of the PG text. Alright, the dot is in the center and camera को भी बना दिया है dot render. Okay, then I need to put it here. Um, how do I use to render background, render texture create, texture destroy, texture load from file. Okay, texture underscore render. Good. No. Okay, 000 G texture dot render. अच्छा clip. Okay, so basically clip provide कर रहा हूँ मैं इसको. Right, clip. Okay, I'm clipping the texture. All right, clipping. We are clipping the texture. We are only taking a specific part of the texture. Okay, अब मेरे को समझ में आया. So we go texture render. I think render provide करना है. और क्या provide करना है इसमें? Render texture है मेरा PG texture. और क्या provide करना है? XY position and clip. So 0 0 and the 0 0 and clip. Alright, then we render the dot. And मेरे को इसमें से कुछ फालतू के फंक्शंस I think I hope I mean पहले एक बार कंपाइल करके देखते हैं. Like dot move conflicting int and dot h. Okay, इसमें अपडेट करना पड़ेगा मेरे को obviously. Dot move और ये भी I think level width और level width और level height shift कैरेक्टर ये सारे नहीं चाहिए. That is all we want. Dot circle collider नहीं चाहिए. ये भी नहीं चाहिए. ds dot c कहाँ है? इधर ही होनी चाहिए. Okay, yeah, dot c. create collider, new dot collider, कोई जरूरत नहीं है. ठीक है, बट मेरे को ये चीज़ नहीं समझ में आई अभी तक कि इसमें से कैमरे की पोजीशन की क्लिप को माइनस क्यों कर रहे हैं. नहीं चाहिए ये फंक्शन, नहीं चाहिए चेक सर्कल, नहीं चाहिए, नहीं चाहिए, नहीं चाहिए. रेंडर, मूव एंड एलिमेंट क्रिएट, बस चलो. ओके, डॉट रेंडर 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 रेंडर, इसी रेंडर डॉट एक्स और वाई. ओके, तो इसमें कैमरा डॉट एक्स एंड कैमरा डॉट वाई को प्रोवाइड करना पड़ेगा, जो मैं भूल गया हूँ. कैमरा डॉट एक्स, कैमरा डॉट वाई, dot height. Yep. Level width. This is unclear. Dot height. Dot height. 102. Okay, you will see. Get collider. Expected token before 78. I don't think it should be a problem. You see. Camera. Yep. Exact as it should be. और क्या दिक्कत है? और दिक्कत है डॉट मूव 102 पे, वॉल डॉट 102 पे. ओके, 102 पे ही. फिर डॉट विथ. यप, ये मैंने गलत कर रखा है स्पेलिंग. राइट. expected expression before. She had declared, right. Is student is correct. Yep. Dot with. Okay. I think I will make them extern constant dot with k dot well dot well. Okay, so right, dot with undeclared. dot width dot underscore. Oh, spelling mistakes. Expression. Mm, 78. Kim.c. Okay. Check orange. Let's unlock camera. Expected expression. Yes, camera isn't camera expression. Have I made some spelling mistakes? CAMERA. Yes, and CAMERA. Indeed, it is an expression. So, multimedia. This is global, right? Camera. Expected expression. Expected expression before token. Why? Why would you do that? See, with camera, it is what is wrong. I don't understand. Do you have to go camera dot x equals? Oh, I think we can only initialize it this way, maybe, and then I have to provide these values manually. I think that is what is happening here. Okay, hold up. Level width 1280 by screen width. Okay, but the camera is not centered. Okay, the level is bigger as compared to the screen. Alrighty, alrighty. Okay, so let's see why. Nope. Alright, must have done something wrong. Um, Here and move. Camera height. Camera dot y. This camera dot h. Okay, this should be okay. Level width. I think level width was its level width. Okay, but the camera, uh, when it moves down, the camera is not centered, right? So when it moves down, its Y value is being updated. Center the camera. Dot position dot Y. Oh, minus. There we go. And it is fixed just like that. Then when it will be in the center. Okay, so I need to, what happens? Okay, so my assumption was kind of wrong, and I would need to extend it, extend it. All right, come here. Okay, so let's think about it now. Better. Okay, this is our level, right? This is our level. Then inside it, this is our screen. Screen or camera, whatever you want to call it here. This is the screen. Slash, forgot the N. Camera, right? Okay. Now this is the screen and the camera. So we have a dot in the middle, right? Okay. Now if camera's position is less than x, this is 0, which is screen basically position is shifting, and camera dot x is greater than, okay, so it's the same. See, b, this position, right? So see, we are bringing, when it reaches here, we are checking for it if this point reaches here, and similarly if these 2 points reach there, it's quite same. Then see, we center it Okay, so what we are doing, we first center it, right? So that it don't collide. What we do is first we center it, like if our dot is here, just here, and we put our camera, our screen here. See, okay. Um, Now, as the dot will move, right? It will go here. It will try to center it, but it will check the condition and it will move it back. So the dot will move, but the camera will keep, and again it will keep on center. Okay, so it is centering it again and again and checking all the conditions. Quite easy. Okay, we move here. Okay, this is the end. Alright, so it is moving, 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 and here we go.